And we are still in section 4.7, antiderivatives for Calc 1. And we're looking at example 73, but before we do that, we want to take a quick look at what are called the antiderivative linearity rules. Again, I don't really care about the names of the rule, but just understand this constant multiple rule means I can basically leave this constant in front and kind of forget about it and just leave it there in front, right? So in other words, the antiderivative of k times little f of x is just k times capital F of x, and then don't forget to add your plus c's. So k is a minus 1 as well. These are the same rule basically, but they call it the negative rule. And then if I take the addition or subtraction of two functions, I just addition or subtract their two antiderivatives as well. And I don't need to add two c's because they're both arbitrary constants, so just add one c. So let's say we want to find the general antiderivative of little f of x equals 3 square root of x plus sine of 2x. So you do it piece by piece. You think of this as 3 times x to the 1/2 power. So just leave the 3 in front to find its antiderivative. Now the antiderivative of x to the 1/2, you add 1, so 1/2 plus 1 is 3/2, divided by 3/2 is the same thing as multiplying by 2/3. So it's 3 times 2/3 x to the 3/2. Sine of 2x, what function if I take this derivative gives me sine? Well, that's negative cosine of 2x, but that's a kx, so I got to divide by 2. So divide by 2, so I get minus 1/2 cosine of 2x. And then add your plus c. So I could simplify this a little bit to write this as just 2 times x to the 3/2 minus 1/2 cosine of 2x plus c. Take its derivative, right? I could get 2 times 3/2 times x to the 1/2, so that's this guy. And then minus 1/2 times the derivative of cosine is minus the sine of 2x times 2. The 2's and the minus signs cancel, so you get 3x to the 1/2 plus sine of 2x, and that's a quick check.